Hello everyone, let's go ahead and take a look at patterns with perfect squares. Now what is a perfect square? A perfect square are going to be numbers like this, 1, 4, 9, and 16. Now the reason why those are perfect squares is because we can rewrite them in the form 1 squared, 2 squared, 3 squared, and 4 squared, and so on. So that means then is that if you have what is called a perfect square, it's a whole number that can be written in the form a squared. So all of these numbers here at the top, they're all perfect squares because we can write it as a number squared. Now, we want to know your perfect squares up to 15 squared. So for example, do you know what 14 squared is? Do you know what 13 squared is? Sometimes people don't, but it's going to be to your advantage to know all the way up to 15 squared for the purposes of factoring as well as for the purposes of distribution. Now what we're going to do is we're going to apply patterns of perfect squares to binomial multiplication. So say for example, if I have the quantity a plus b squared or the quantity a minus b squared. Now notice that we have a binomial, but it's a perfect square because that number is being squared. Now, if we expand this using FOIL, basically what we'll come out with is a squared plus 2ab plus b squared, and for a minus b quantity squared, we're going to come up with a squared minus 2ab plus b squared. Now there's also going to be another special binomial product that we want to consider, and that one is this one. It's the quantity a plus b times the quantity a minus b. If we FOIL, we come up with a squared minus b squared, which is the difference of two squares. Now, what we've looked at right now is looking at the perfect square form to its expanded form. Perfect square, or well, this isn't necessarily a perfect square, but it's going to generate the difference between two squares. Now, if we go ahead and expand, we come up with this particular pattern. In addition to being able to expand, you also need to be able to factor. So in other words, if you see something that follows this particular pattern here, we need to also be able to factor to this perfect square form. If we see the difference of two squares in this form here, we also need to go ahead and be able to factor to this special binomial product. Okay. So let's go ahead and take a look at a couple of examples. Now, with this particular example here, I have the 4x minus 7y quantity squared. Now, say for example, if you forget these particular expansion formulas, well, you can always just go ahead and rely back on FOIL, because that's basically what you're doing. We have the quantity 4x minus 7y times the quantity 4x minus 7y, and if we FOIL, we come up with 16x squared minus 56xy plus 49y squared. Now, how do you apply the formula to this particular situation? Now, if we go ahead and compare what we have here to what we have here or here, which form is closest? Well, I would suggest this one here. So if we go ahead and let a be equal to 4x, and we let b be equal to 7y, then of course I have the a minus b equaling, of course, this expanded form. And then if I resubstitute what a and b are, I can very simply come up with exactly the same expanded form of this particular perfect square. Now again, we want to also go ahead and take a look at factorization. Factorization can at times be more difficult. If we go ahead and take a look at x squared minus 2x plus 121, say for example, the first thing that needs to happen is that you have to recognize that 121 is a perfect square. It's 11 squared. So if it's 11 squared, then I take a look at this particular middle term or the linear term, and I say, oh well, look, there's an 11 in there, and it's 2 times 11. So what I have now is I have x squared minus 2 times by 11 times by x plus 11 quantity squared. Hey, that looks just like this particular form here, where a is going to be x and b is going to be 11. So what I can come out with is x minus 11 quantity squared, or if I wanted to go ahead and rewrite this using two particular quantity brackets, then I know that this is going to be x minus 11 times by x minus 11, of course, which is x minus 11 quantity squared. Now, in addition to that, say for example, if we go ahead and take a look at that one there, it says 2x squared minus 2. Now, 2 is not a perfect square. So what we need to do though is, first of all, as any time when we want to go ahead and factorize, is look for our greatest common factor that we can take out. and in this case the value is 2. So if I factor out the 2, which is the greatest common factor, I get x squared minus 1. Again, the key to recognize here is that 1 is a perfect square. It's 1 squared. So now I have the difference of 2 squares. So what I know then is that being that I have the difference of 2 squares, I can rewrite this particular quantity here in this form, where a in this case is going to be equal to x and b in that case is going to be equal to 1. So I know that I can rewrite this particular factor here, or this particular binomial, into the form x minus 1, or x plus 1, and x minus 1. Okay, so let's wrap up. Basically, we're going to be looking at perfect squares. Of course, it's going to be important to know what a perfect square is, and know your whole number perfect squares up to 15 squared, so that it can help us to be able to distribute or expand binomial perfect squares, and also help us to factor quadratics that involve perfect squares. So we have 2 particular perfect square expansions that we need to remember, as well as recognizing the difference of 2 squares so that we can factor into this special binomial product. Okay, and we'll go ahead and take a look at some examples, and we'll also go ahead and look at some of those problems the next time that we meet in class. So see you next time. Bye-bye.